Hi, welcome back to Algebra 2. We are looking at section 10.2 today on simplifying complex expression. I'm pretty sure the title was something else, but what are you going to do? I completely don't remember what it was called anyways. Okay, but to get started, what I would like to do is, well, let's start with getting a pen that works first. There you go. Okay. Let's go ahead and start with reminding everybody what I stands for. So I is equal to the square root of -1. Now, if I take that expression, if I take that equation and I square both sides then, the result is that I'm solving for I squared. And on the right-hand side, we get the square root of -1 times the square root of -1, which in turn is equal to -1. So that's how square root works, because that number times another number with the same square root just gives you what's inside the square root. So that is going to be our result. Keeping that in mind, we're now going to go forward and solve for what is I cubed. I cubed is the same thing as I squared multiplied by I. So if I take what I put previously, then that is the same thing as -1 multiplied by -I. So the answer is equal to -I. And finally, when we have I to the fourth, we are going to write that as I squared multiplied by I squared, which is the same thing as -1 times -1, and that is now equal to 1. So if we put it all together, then that means I is just, well, equal to I squared is equal to -1, I to the third is equal to -I, and then I to the fourth is equal to 1. With that being said, we can use this now to our advantage for all the other stuff, and you'll see that there's going to be a pattern that's going to be very nice about this. Let's say for now, what I need to do is I want to go further and say, hey, I want to solve for I to the fifth then. So just using a different color here, let's use I to the fifth. I to the fifth is the same thing as I to the fourth multiplied by I, and so that's equal to 1 times I, which is equal to I to the sixth is then going to be, and let me give you a little bit more space over here, I to the sixth is equal to I to the fourth times I squared, which is then equal to 1 times -1, so it's equal to -1. And I think you can kind of see what's actually happening right now. So I to the seventh is equal to I to the fourth times I to the third, which is 1 multiplied by -I, so that's -I. And then finally, I to the eighth is I to the fourth times I to the fourth, so that is then equal to 1. Now, if I write that out on the side, just like I did previously, I to the 5 is I to the 6th is equal to -1, I to the 7th is equal to -I, and finally I to the 8th is equal to 1. You'll notice you take all of these guys right here and then compare it to what I had previously, you can kind of see what's happening now. Anything that is to the fourth multiplier of 4, the answer is going to be equal to 1. So for example, I to the 4th is equal to 1, I to the 8th is equal to 1, most likely I to the 12th is equal to 1. Previously to that, I to the 3rd and I to the 7th are going to be the same thing as equal to -I. And then I squared and then I to the 6th is equal to -1. And finally, just I or I to the 5th is equal to 1. So if we use that to our advantage, we can actually solve for larger values of power of I. So let's go ahead and do that right now. Let's go to the following, where I want to solve for maybe, or simplify, what is I to the 50th. Now, what I can do is I can say, hey, let's compare I to the 50th to maybe some sort of multiple of 4, because 50, well, we can kind of split that up into two different parts. The way I see it is this is the same thing as I to the 48th, because that is the closest multiple of 4 without going over. And then there is going to be a remainder of 2. So 48 plus 2 is equal to 50. And if I now write this out, that's going to be I to the 48th multiplied by I squared, and that I to the 48th, that's the same thing as 1, because as we said earlier, anything that is a multiple of 4 in the exponent, that's equal to 1 then for I. Whereas I squared, going back to it one more time, that is now going to equal to -1, because that's a remainder of 2. So put it all together, the answer is going to be equal to -1 then. Okay. For I to the 93, we can use exactly the same idea. Again, first things first, we're going to go ahead and rewrite I to the 93 as a multiple of 4. So 93, I am looking at it as 90, and then we have plus 3. Try always not to go over if you can, because that just makes your life a lot easier. I to the 90th power. Ooh, I think I did it wrong for this one. Let me kind of go back because I just checked myself. The closest multiple of 4 to 93 is actually 92. So that means this is going to be I to the 92 plus 1. And if you want to shorthand it, because I to the 92 is equal to 1, then all we have left is just I to the first power because of this remainder. So I to the 1 power, the answer is going to be equal to I then. I to the 61, same thing, right? We're going to go ahead and write that as I to the 60 and then plus 1. So with a remainder of 1, then that means that this is equal to I to the first. So the answer is going to be equal to I. Now, if your exponent is negative, you're just going to repeat the same process. You don't actually have to worry about changing this to 1 over I to the 124. The way you look at it is, hey, every multiple of 4, again, is going to be the same, is going to give you the same thing. So what I can do is I can take the following, that what I have, right? If I want to go ahead and get out the negative, I'm going to go ahead and say, let's go ahead and add something that is a multiple of 4 because that should give me the same result. So fortunately, 1024 is a multiple of 4. So that means if I add 1024 to the exponent like this, that should then give me the same answer. Because if you look back, right, I to the 3rd is the same thing as I to the 7th. It's the same thing as I to the 11th, and so on and so on. Every time you add a 4 to the exponent, they should be the same thing. So here, no difference. I'm just adding a multiple of 4, so that should then lead me to the same answer. And fortunately, because of what I have, that now gives me I to the 0. And I to the 0, even though we didn't talk about it, hopefully you can see the answer is equal to 1, because I to the 0 is the same thing as I to the 4th minus 4. So that's going to be I to the 4th divided by I to the 4th, which is equal to 1. Because, you know, same thing divided by itself is equal to 1 then. So there you go. That's going to be our simplifying for imaginary numbers in general. Now we're going to go ahead and look at what happens when you multiply them or divide them. In the first case, we have 5 minus 2i quantity squared. Write it out as a FOIL just so that you know what you're doing, because remember, you cannot distribute because of that minus sign right here, right? You, again, do not want to do this mistake, the freshman's dream. A minus b squared is not equal to a squared minus b squared, nor does it equal to a squared plus b squared. So these two are a big no-no. Rather, you're supposed to use FOIL to multiply it out. So 5 minus 2i times 5 minus 2i. That turn gives us 25 minus 10i minus 10i, and then we have plus 4i squared. Combine all your like terms. 25 is just 25 minus 10i, that's a total of 20i. And remember, I squared, that is equal to negative 1. So what you have in the end is actually minus 4. So cleaning it one more time, 25 minus 4, that's equal to 21, and then minus 20i, and that is going to be your answer. Next one, same thing. If you want to try to do it yourself, you know, maybe pause the video and then try it and see if we can get the same answer. By all means, go ahead and try that. But if not, I'm going to go ahead and go forward. Again, you're going to go ahead and use FOIL and multiply everything out. 6 times 5i, that is equal to 30i. 6 times negative 2, that is going to be negative 12. 3i times 5i, that is a total of 15i squared. And finally, 3i times negative 2, that's equal to negative 6i. Same as before, we're going to combine your like terms. 15i squared, that is going to be negative 15, which I will then combine with the real number portion. So this will give me negative 12 plus 15. Oh, sorry, not plus 15, but rather minus 15. So that is going to be equal to a total of negative 27. Take your imaginary part and do exactly the same thing. Add them together. 30 apples minus 6 apples, that's a total of 24 apples. So that is going to be your answer then. Know what's happening is that every single time we multiply out an imaginary number, like two imaginary numbers, the result is that we get imaginary numbers as well. Or actually, more specifically, when we take two complex numbers and multiply them together, the result should be a complex number, right? A plus bi, and then you get a plus bi. The final example that I have for you is, well, what happens if we divide by a complex number then? Well, remember, I is supposed to be equal to the square root of negative 1. So what I have is really like saying 4 and then plus square root of negative 1 divided by 3 minus 2 times the square root of negative 1. if you remember the previous sections, I don't like having square roots in the denominator. So what we'll do is we're going to multiply something to both top and bottom that will get rid of the I part. And remember, it's not going to be 3 minus 2I because that is not going to get the job done, since when you square something, it still gives you the I term. But what you are supposed to do is multiply by, hopefully you remember, the conjugate. 3 plus 2I then, to both top and bottom. So in doing so, the bottom part, that is a difference of square. So first we'll write that part out, and let me go ahead and shift this guy down a little bit. Ooh, I love technology. Okay, difference of square. A plus b times a minus b. That is going to say a squared minus b quantity squared. And make sure you write that parentheses in there. Whereas the top part, you're going to have 4 plus I multiplied by 3 plus 2I. Once you do enough of these, you could probably skip all that step right there and just go straight into multiply. But, right now I just like to do the work. Let's see. Bottom, that is going to say 9. And then the bottom part is going to say minus 4I squared. The top part, when we multiply that out, that is equal to 12. And then plus 8I plus 3I. And then finally plus 2I squared. And once again, we'll take care of the I squared part first. The I squared will make it negative. So that means I have 9 plus 4 on the bottom. The top part, this guy, that is equal to negative 2. Combine that with the 12, so that's a total of 10. We have the 8I plus 3I. That's going to be plus a total of 11I then. So your final answer is 9 plus 4, so that's 13. So let me go ahead and write that in there. So cross that out, and let's go ahead and put that 13, and that's your final answer there. Hopefully that's pretty straightforward. Now, last part, and I don't want to, spoil your fun, but I think, just worth mentioning. If we can square a complex number, shouldn't we be able to then take the square root of a complex number? So my question to you is, what is the square root of 4 minus 3i? Well, I don't want to spoil your fun, so I would like for you to, give it a shot just to see if you can figure it out. What I would recommend is, well, actually, I'll give you two things. One, I will give you the answer, so then that way you can kind of verify a little bit later on to see if you can get it correct or not. The answer should be 2 minus I or negative 2 plus I, because if you recall, you take the square root of something, then that means that you should have two solutions in this case. And it's not like, unfortunately, it is not like the real number where if I say square root of 9, the answer is equal to just 3. It's kind of like going backwards. You're trying to find two numbers, but when you square them, you'll get the same thing. That then leads me to the clue that I want to give you, right? If you want to go ahead and solve for this, or if you don't want to hear me say it, maybe you should try it yourself first. But if you do, here's what I'm thinking of. Why don't we look at this as the following? 4 minus 3i. I'm claiming that that's going to be the result of some complex number. Let's go ahead and say a plus bi quantity squared. So once again, if I take the inside of the square root 4 minus 3i, I'm claiming that that is going to be some complex number a plus bi squared. Well, your job is to find out what a and b are equal to. So I'm going to leave that to you. Figure that out. Okay? Like I said, the answers are there. Just go ahead and give it a try. Try to leave it in the comment if you want to. All right. Thank you so much, and I'll talk to you later. Bye.